We'll definitely test Friday, just so you guys know. It will go Friday. It won't be a big deal. This is there's only the 4 sections in this chapter, and honestly, I think 3 of them are all about the same thing. So
yeah, this reminds me of section 1.
Yeah. Yep. So with these things here, you're going to see stuff, and I'm just going to show you a picture and explain what it does. In this example, you'll notice that you have a triangle with one set of parallel sides. It doesn't necessarily say that it's a mid-segment. It just shows that there's another segment within the triangle that's parallel to one of the sides of the triangle. When that happens, think of this piece as a fraction bar. You wind up with segment over segment equals segment over segment. So when you have a parallel side in a triangle, think of it creating the fraction bar. It is such an unwinded version of the actual material here. But you guys see how that segment RS, see how it's parallel to the base XY? That RS value, I want you guys to think of this as the fraction bar splitting a numerator and a denominator. A numerator, a denominator. Anytime you see a diagram that looks like that, that will always work. Okay. So I could write out the ratios then that QR is to RX equals QS is to SY. That's what I mean by that little bar in the middle piece acts as a fraction bar. It is I'm trying not to use all the bad language that, I don't mean like 6 words you can't say on TV language, but the 7 words, sorry. That you can't say on TV, but the long-windedness of some of these definitions in this textbook. When you see that, think of it as it splits it into 2 fractions. Fraction on the left equals fraction on the right. Okay. Okay. Let me show you an example. Oh, one thing I did send out for all the email stuff here today. If you guys haven't already gotten a multi-view, we're about a week away from starting trig. You kind of need to have it. Otherwise, you're going to be simplifying radicals by hand. I mean, just to let you know, we got plenty of them. So we haven't sold out. So yeah, those calculators can simplify square roots. But all right, see in this case here, that KL, that second KL is parallel to the second PN. So think of that KL segment. It creates the fraction bar. So your ratio would be 12 over x plus 1 is 9 over x. It's easy. See what I'm saying by it makes that fraction bar going across? If you just think, once you see that in a diagram, if they're parallel, that's the thing. They have to be parallel. If they're not parallel, it doesn't work. But as soon as they're parallel, that happens. So you just overdraw it, and all of a sudden, dun, 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 you've got fractions. So you would cross multiply. Distribute. Then what? Solve, right. Subtract the 9x. Josh, I saw you throw your hands up a second ago. You're right. It's really nice when we're drawing these things out like that. Really, really, really nice. And I think the next one is the same thing, but it just doesn't make it right. Yep. Okay. Not too bad. So if you see that parallel side, think of it as a fraction bar. It's the easiest thing in the world. I don't want to skip ahead. I don't want to do too fast. Do you want to do another one? Again, I don't want to write out a whole bunch of weird words and definitions and things. I just want to show a diagram. Sometimes you get, don't worry about this. Sometimes you have 3 parallel lines and 2 transversals. If you guys ever looked at land plots, property lines, DeKalb's assessor's office, you guys know what an assessor's office does? Property tax assessor, they look at your prop lines and they do all your taxes before they charge you your taxes. There's a really cool website for DeKalb County. It's the QTAS search. You've seen this? What it does is it's a satellite imagery of your property lines. It tells you all your degrees and your minutes and everything for all your property lines are. And it draws it up on like kind of the Google Earth map. And most property lines, if you've ever noticed, like your next door neighbor, your property lines are usually parallel to one another. And then obviously your front and backyards are usually ones that curve and whatnot, but usually everything else, the side by sides are usually parallel to one another. So you can see this in a satellite imagery where property lines switch through, kind of like this idea, so you can get the proportionalities of it.
Our property line comes to the middle, the yellow line on the state road.
Oh, really?
So I wanted to put on my
That'd be great. That'd be so cool. Yeah, it's kind of cool when you can start looking at lines and stuff. You guys know that in your house corners you've got the metal stakes. You ever seen one of those? If you go to where your property, if you built a newer house, it's easier to find because it hasn't been like sunken in a lot. If you go to your corner where you think your property line is, and you start messing around with it, start feeling around, you might find like a metal rebar that's been hammered in there, and that tells you where your property line is. So it's pretty common. You guys have those even out with the farm? Maybe.
No, and we're on the farm, so
Yeah.
what happens on the farm is one of them here every year, so that's just a little bit more.
Yep.
A little bit more than I think. I used to be able to mow a whole big
Road.
swath of grass, and where is that? Oh, now it's that one.
And you know what? We do the same thing. My backyard backs up to a cornfield, and we have a berm that comes up to it for the backyard part. And between my property and the farm field, there's what they call an easement, and it's like a drainage easement. It's about 8 foot. I mow it back a little bit, so just get a little bit more space on top of the hill there. But you know, farming, it's just an easement. It's not doing anything. Yeah, right. So in this case here, again, when you have the 3 parallel lines, think of the middle one as the fraction bar. Think of this middle line. There's your fraction bar. Numerator, denominator. Numerator, denominator. Every time. That's how clean this stuff works. Now, was it, I think it was you were saying, remember how we had the one image where it was rotated from what we did yesterday? I said, hey, turn your page. It's going to be the same idea. You're not always going to see these going left and right. Sometimes you see parallel lines going vertically. Turn your paper. You're always going to be able to see that middle line will act as a fraction bar. That's why they say AB is to BC as WX is to XY. It's again, a super easy visual thing that we can do in this class, or in this case, excuse me. Example-wise, when you see one, didn't realize I was talking about plot of land there. See how it's got the 3 parallel lines? You have your 3 parallel lines, but in this example, see how everything's going vertical? If I tilt my head sideways, they go horizontal, right? Horizontal-ish. Now, doesn't this act as a fraction bar? See how that works? It's super easy to put it together like that. And you've got your fraction bar of 70 over 56 is x over 62. Just by turning sideways, it picks it up quite a bit. Not necessarily. That's right.
If we wrote 56 over 70, what would we have to write on the other one? Yeah.
Exactly. So if I turn mine clockwise, if you turned yours counterclockwise, it still acts as a fraction bar, right? So you had 62 over x, 56 over 70. And aren't they just flipped images? Remember, because remember, whenever you have ratios, as long as you're consistent, you can flip them and do consistent stuff without, and it works out just fine. So yeah, you were thinking in terms of radians, because that's why you went counterclockwise, because that's how you count degree measurements. She's like, I don't know. So if you cross multiply this out, what do you get? 77.5. Anybody else agree, disagree? Okay. There you go. Super visual, super easy to set up. As soon as you see those 3 parallel lines, think of the middle one is always going to play the role of fraction bar. All right. This next, oh, you're gonna love the next one. Yeah, you will. You're gonna love the next one. Sometimes you have an angle bisector. And an angle bisector does what? Cuts an angle in half, correct. Now, what's crazy about an angle bisector is that if you draw the angle bisector to the other side, see how it creates 2 triangles? Those 2 triangles have similar sides. Those 2 triangles become similar. Now, what I mean by you're going to love this one is how your ratios work. This is probably one of the dumbest things that I've ever come up with, and I've come up with a lot of dumb things in my life. This is probably the dumbest, but it makes a lot of sense. It's so bad. It's like a bad heart. When you have this, at least you can draw it better. If I have a triangle, this is my angle bisector. You love it. See how I made a heart? It's so bad. But here's what happens. If you go from the angle bisector out, so let's say this is A, B, C, and D. Numerator, denominator. Numerator, denominator. You love it because it's got a heart. Numerator, denominator. Numerator, denominator. As you're coming out and around because you love it. I'm telling you, it's the dumbest thing in the world, but you won't forget it because if you draw a heart around it, you're creating your fraction, numerator, denominator. Or if you work your hearts backwards, you're coming back this way. You can say that out in front of you is the numerator, the side of you is the denominator. It's fine because we were saying earlier, as long as you're consistent, it's okay. Let me show you numerically how this works. I'm going to spin this so you can see the heart better. So apologize that this is a 25, 15, 6, and that's an X. So if I love my problem, it's great. Because you love it. I'm telling you, today's all about dumb stuff that help you remember things. You got parallel sides, make fraction bars, you got things that create hearts, it's other shapes, whatever. So if you look out, here's your numerator, denominator, or numerator, denominator, however you draw your heart. If you're one that draws the heart from the bottom out, then your sides of your heart could be your numerators. Trying to sound poetic, it's almost Valentine's Day. You're one that starts the hearts away from you and brings them in. As long as you're consistent, it's fine. So, also notice it captures the one fraction. It captures the other fraction on either side because the split in the middle doesn't cross. You want to double cross your heart. You don't get this kind of humor in English, I know. You're like, thank God. So if you cross multiply this out, let's see, if you can simplify it first if you want. That's what, 3/5, I believe? So you get 3x plus 30. Or if you did it the opposite way around, you just have your fractions flipped. As long as it's consistent, it's okay. Told you you'd love it. I know. All right, you try this one. And make sure you show it some love. I'm sorry. Every time I bring up a bad pun, you're just looking at it going, really, Murphy? Cut it out. I told you it's stupid, but it's stupid, but it works. So if you love this problem with all of your heart, and of course, all the time I get a good bad pun here. Just throw our leaves. It's stupid. I know it's stupid. Don't throw my heart away. Cross multiply and solve. Simplify first if you'd like. If I simplify this, I get 5/6, I believe. So 5x would be 6 times 18. Divide that by 5. And yeah, you will get you got a halvesy on this one, didn't you? 6. It's fine. It's okay. You get decimals. If you're getting like 0.278443796, you probably screwed something up. If you get like a 0.6, 0.5, 0.75, quarter, something like that, even thirds, sometimes those are all going to happen. It's not a big deal. You get those that are just really, really out of whack, especially for now. Don't get me wrong, we'll get to some really weird fractions or more or less decimals when we start talking about trigonometry. When we start trying to find angles and sides and stuff like that, you're going to get really crummy numbers, and it's okay. It's still going to be dependent on how you set it up. Oh, I closed it. Excuse me. Take a second. It's almost due. Please and thank you. Love looks like a kidney bean in that one. Now, does it matter if I write 4 over 8 is 4 over x, or do I have to write it as x over 4, 8 over 4? Doesn't matter. What's x? 8. It's got to be, doesn't it? Has to be. What kind of triangle is this? It's equilateral. Very good. Because you have 8, 8, and 4 plus 4 is 8. 16, that's the one that has the 3 parallel lines. So think of the one in the middle is the fraction bar. So depending on which way you tilt your paper or tilted your head, did you say 3 over 2 or did you say 2 over 3? 3 over 2, okay. So if you said 3 over 2 by tilting it to the right, that, yeah, I'm writing it sideways. That means what's going to be on the numerator for the other side? Cross multiply out. 3x is 7, x is 7/3. And there's an example of when you're going to get a crappy decimal. It's okay. I would leave it as a fraction because when we get as we get going into more complex stuff, improper fractions, which is what this is, and are going to be the norm as opposed to other things. Especially as you get going into, like, kind of, to be honest with you, I'm trying to prepare you guys to when you start seeing stuff in Algebra 2 about why they always like to leave things in fraction form. So I'm trying to start to get that going into you now, just so you get more practice with seeing those. And to be okay by seeing a fraction like 7/3 and not have to rewrite it as 2 1/3. Remember, don't use mixed numbers. They're just kind of silly. There's, like I said before, I think there's only going to be one time in your lives that you're going to use a mixed number ever again that makes any sense. Much easier to do these. Are we good on this? It's a lot quicker than I anticipated. You turned on me so fast on that. You're like, yes, this is good. And I loved it. The look of disdain. It's like, come on. Try to have a little bit of fun. I'll put the book up on the board here in a second, but this is section 7.5. So it's on page 475. We'll do 9 through 12, 15 through 22. Ooh, I want to show you how to do one of those real quick. And then 33, 35, and then we should be good to go. There is one, I'm going to show you a quick little setup for a little trick for number 22. I'll just draw this real fast. If you guys want to start your homework problems with number 22 being the first one, I'll give you a hint on how it starts. I'll give you a little hint on how it starts out. Because this does show something like this. This is kind of like what you were asking about earlier about the whole lengths, about what you have to do sometimes. Okay. We had 3 different examples today. We had a triangle with a parallel side, we had 3 parallel lines, and then we had the ones that we loved, the angle bisectors. Which of those 3 is this? The angle bisector. Let me slide this up some. So the angle bisector is the one that you love. You go out and come back around. Now, when we go out and around, we have one value here, x over 6, and what would the other side be? Very good. The other side here, if the whole thing is 6, this chunk is x, oops, that means this chunk has to be 6, subtract the x. Okay. I just wanted to make sure I showed you guys, because from time to time they will put something like that together. You just have to be cautious with it. Okay. It shouldn't be so bad. If you give me a second, I'll put those, the beginning of those problems if you don't have your Chromebook in front of you. We get started on them. You guys want to listen to your music, whatnot, while you're